Hey, look at that. Big terminal. I always have the font that high. Works out. Okay. We'll warm up with a little presentation before we start doing the terminal stuff. I already introduced myself, but I'm Alex Polvi. I want to give you guys just a little background about CoreOS, why we're building it in the first place, and then we can get on the terminal and actually show you guys some stuff. Has anybody here played with CoreOS at all? Yeah, a couple folks. Okay. How about NCD, the distributed stuff? How about systemd? This has nothing to do with CoreOS. I mean, we use it, but we didn't build it. We use systemd, yeah, okay. Cool, so those are the technologies we'll go over. But a little background on CoreOS. So at the highest level, CoreOS is a platform for the platform builders. That's a little bit nebulous. I prefer to call it the undercloud. I don't think our social marketing team really likes that so much, but I like it, so I like to call it the undercloud. So the idea is it's the distro you put underneath kind of your cloud platform. So if we were talking to like Amazon, for instance, we would be trying to convince Amazon to use us on their bare metal below their actual software that controls the cloud platform. Or same with Rackspace and so on. But of course, you can run us inside of a virtual machine as well. We're a Linux server distro, similar to Red Hat or Ubuntu. So wherever you can run Linux, you can run CoreOS. Why did we start hacking on CoreOS? This was an article that came out a couple weeks ago before all the Heartbleed stuff. But just this, especially with Heartbleed, there are servers that will forever be out there that will be compromisable just because they won't get an update. People have forgotten about them, or people don't know that they're vulnerable or know that they need to do something. And the root idea is if we could do something about this, we could maybe make a big step forward on the internet for everybody. So the idea behind CoreOS came originally, it's slightly inspired from the browsers. That might be a little counterintuitive, but do you guys remember in 2003-ish or 2-ish, or when IE5 was the bane of like every IT guy's existence? It was getting compromised all the time. What was that?
It was a dark time.
It was a dark time. There was like, they had 90% market share. It would get compromised. It would take Microsoft like months to get a patch out, and it was just a mess. And that's what allowed Firefox to even come up in the first place. Was, we need a lighter, faster, more secure product. And so Firefox made a lot of headway there. I was working at Mozilla at the time. I was a 12th employee at Mozilla doing server stuff. That's where I became a server guy. You might not think Mozilla has a lot of server infrastructure, but when you have 100 million clients of anything, checking for an update or trying to grab an add-on, it adds up pretty quickly. But anyway, so what happened though was Chrome came along, and Chrome did something quite a bit different than these other guys. And what Chrome did was, instead of waiting for Microsoft and then the IT guys to apply the patch to the browser when there's a security problem, Chrome just automatically did it for you. So, and that's how Chrome works today. If you have a security issue, you just get a patch and it gets applied, and when your browser bounces because you reboot or crashes or they annoy you enough with their little red dot, then you restart and you're on the latest version. And this freaked out the IT guys all again, right? Because you can't go changing out software out from underneath a running system. That's like an online civil liberties issue. It's also a issue just around, well, what if they break something, right? But what happened over time is we realized that this is actually a better way to deliver. Google can administer all the browsers in the world that are under their control and secure them and update them better than any individual little team could. So when IE and Firefox followed suit, which again they do today, I believe we got the most secure internet that we've ever had on the front end. And we've also gotten some nice things like HTML5. When these three guys decide on something and then they roll it out, they can upgrade the browser and upgrade JavaScript kind of overnight in a way by doing it, so they can upgrade the web. Well, we got nothing like this for servers. For servers, state of the art is get it running and then don't touch it because things are too fragile. So our idea was if we could build a distro that was as easy to update that we could unlock a lot of value. And that value is around security, but it's also around the feature richness. It's also around just capabilities of a modern backend server environment. But to do that, it's a lot harder because on a browser you can take a little downtime, but on a server you can't take a downtime. So we've had to bring in a lot of new components as well as build some ourselves to start realizing this. Well, these are kind of the things we'll show off today. The way they integrate with CoreOS. Systemd is our init system. If you haven't used Systemd at all or haven't used it, you should start checking it out. RHEL 7 is going to ship with it, which means CentOS will follow. Debian and Ubuntu both said they're switching to Systemd. Ubuntu from Upstart, Debian from sysvinit, booyah. Welcome to 2014, everybody. So since RHEL is shipping it, sometime later this year, that means, I know there's RHEL folks in the room, so I'm just prodding for fun, but if it ships later this year, it means it should be adopted in about 5 years or so, which means you have about 6 years before you need to worry about no, it's just, there's all those migrations, but just poking, just fun. No? Okay. So NCD, the reason we started building these distributed systems components are because we want to be able to allow people to take a machine out of service without taking a downtime. And in order to do that, and that's where you need to start thinking about things as clusters, and that no individual machine has any workload that can't be taken out at any time, and things don't or continue to work as you would expect. And this is like the operations utopia of shoot any box and your environment keeps working. And while theoretically very nice, practically it's very difficult. And so NCD is the first step towards that. It provides the low-level primitives required to do things like a master election or just service discovery, having things dynamically find out where applications are. If you don't know where they're running, you have to dynamically look it up. You can't hard code anything. Fleet is when we take Systemd and we plug it into NCD to allow you to do a distributed process manager. So full-on distributed init system. So now the abstraction we provide with Fleet is you have a Systemd unit, but it's just running somewhere and guaranteed to be running. And if the box it's running on dies, it runs somewhere else and moves around. And again, your application has to be architected in such a way that's actually capable of existing in such an environment. A lot of applications have a hard time being shot in the head and moved and running somewhere else, like what happens to your state, for instance. But it's, again, a tool to help folks get to that path. It's a path. It's a step towards the path of this truly fault-tolerant distributed system. And Docker for us is like a package manager. CoreOS is really, really small and lightweight, and we don't ship Yum or apt-get. We ship Docker as a way to pull in packages and get things going. So all of this, in the Linux kernel, the random utilities and everything you have is, I think coming in around 130 megs right now per host or something. Do any of the guys know what it is?
Actually, it seems like a lot.
It seems like a lot? Oh, yeah.
But
they're a little heavy. It's all those fat Go binaries.
Yeah, 30 megs of that is NCD Fleet and Fleet CTO.
yeah, because Go binaries are.
They're all staggering pop. Yeah, I mean, it's all kind of relative. Like a 10 meg binary, 10 meg JPEG, like, I don't know. Anyway. Okay, so a little bit on the distro and how the distro is architected, or how it's architected differently. So the distro, and this is how distros work today. You take your application and you put it on some checkpoint of all of open source. So applications, the major releases of the distributions are some checkpoint in time, and then patches, security, and other things backported into those applications. And the reason you need to do this is because there's really one version of each of these on that major release of the distro. So what we do differently is we move that line. We support as little as possible. and push all the application and all their libraries into containers. Okay, so with this model, we can rev out the kernel and that base init system out from underneath you and keep it up to date without breaking your inter-application dependencies, because that's what normally breaks. It's not that the Linux kernel version broke, it's that the application version of OpenSSL was expecting broke or something like that. So that's the CoreOS piece, and then these are really containers. Does that all make sense?
Yes.
All right. Here we go. So I'm not a very good software developer, so when I do write software, I try to show it to as many people as possible. And so this is a little tool I wrote to just spin up CoreOS machines on Amazon and Rackspace and Google. Actually, it doesn't do Google yet. It'll be confusing in a second here. But before we actually start launching machines, I want to show you how we do sort of boot time configuration. Who here is familiar with Cloud Init and Cloud Config? Yeah, it's a quasi distro neutral format for doing boot time initialization. It's where you would take this configuration and you put it into like the user metadata of an Amazon machine, and that tells that Amazon machine to run particular setup. So we implemented Cloud Config, and we have some of our CoreOS specific stuff. And what these parameters tell us are, for etcd, use this discovery URL. This is a hosted etcd in the sky that allows etcd clusters to bootstrap themselves using a service discovery. And so we just put this up for convenience. You don't have to talk to etcd.io to bootstrap etcd. This is just a helper. It's saying advertise the address of etcd for the clients on that, whatever the public IP of the box is on 4001. Advertise the peers, so for etcds to talk to each other on whatever the private IP is for 7001. And then this is saying start some systemd units, etcd and fleet. We ship these on the image, but we don't start them automatically unless you want it. And then this is just a cute little trick. This is set the user, the Unix user core, and do an HTTP GET from GitHub of the public SSH keys for the user Polvi. So this is like the cheapest SSO solution you'll ever have, in that it can just pull in public keys. And I just like demoing with this because I have the public keys in my box. And on all the different cloud providers, they have their different key format and way you need to inject it and everything. So it's just like forget about however they do authentication and just let CoreOS do it. You could include, like, you could go authorized keys, something like this, SSH, RSA, blah, 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 blah. You do that too, but the GitHub thing is just a convenience and makes it look a little nicer. So I need to grab a new discovery token. All right, this is where I open my browser and see whatever I was looking at in front of everybody. Okay, oh, good, that thing. Discovery.cdio, so I'm just grabbing a new token. And this is just a little hosted service we put up for free for convenience. All right, now we're gonna core up my tool here. So cloud config equals example cloud config etcd. We want to run, whoa, 1 second. We want to run, and we want to do the number, let's do 5 machines. This is another part of my program I'm particularly proud of. I do an OAuth against Google to get temporary credentials from Amazon in order to continue to authenticate. So you'll notice this called back to my Go app, which was running a web server temporarily, and then it errored out because of a missing image ID. Well, that's not helpful. Dang, this is where live demos bites you. So what's happening is, here's where these images are, and I believe we shipped a release just now, and let's see what my AMIs are. Where is it? AMI all. Yeah, look at that. We don't have one. So we need to launch in US East 1. Region equals US East 1. Anybody know what's wrong with that release from the team? Not Valid ID. It looks like our syntax is just messed up. That looks good. Uh-oh. Demo gone wild. Not sure.
Straight new line.
Polvi, is there any way you can run a specific release version?
Let me see what I implemented. Did I implement image? No, I skip on the image because I always know what image it is. Well, now we get a Go programming lesson. Shoot.
Can you just go
What if you
through
pick-
the cloud formation?
Yeah, the cloud formation just throws me all off cadence.
Was the AMI the last thing on the line?
Sorry, let's see what was going on there. One second. Sorry, this is
Yeah,
embarrassing.
it was. What if you tried going AP Northeast 1?
All right, let's try it. AP Northeast 1. Something's bouncing at me. Not authorized for images. It's because we pushed a release that doesn't actually run off there. And guys, what was our last good release?
289.
289.
I think so. It might have been 291, but 289 is good.
Wait for it.
Hey, you're my life for that.
Hey, look, I do set the channel. So I should be able to do this. I should be able to go channel equals 289.0.0. Is that our version? Let's see if this works. Looks good. All right.
Awesome.
Yes. Okay, so this is what I get for writing software. All right, first step, we launched the machines. Cool. Okay, we got 2 of them. Give it a minute. I could git pull in my code, which I know is in master right now, that blocks on waiting for SSH to come up on these. Okay, so it looks like we got them all. If I have 2, let's pick one here. So if I SSH to this machine, Amazon reports they're up before they're actually up. That's why I added the feature to check for SSH being up before saying it's up. But that feature isn't in the code I'm showing you, so there we go. There it is. Okay. All right. So the main thing here that will prove that all of this is working is, did that etcd bootstrap token make the whole cluster come up, right? And then was Fleet able to register from each machine into that cluster? And to see that, we'll run a command that goes fleetctl list machines, and if this works, it should have 5 machines in it. Hey, we got it. Okay, so our cluster is up and happy. So before we dig into what Fleet actually does, do a little bit of overview, a couple other things. Systemd, your folks want to see the bare bones of Systemd, or is that boring?
Let's see it.
Let's see it? Okay. So Systemd is all defined through through units. So unit is, let's just do like etcd.service. So the etcd.service here is the unit. I'm catting to show us the unit powering that. So this is your alternative to etc init.d Apache 2 start. You now, instead of writing those shell scripts, will be writing these unit files. And these unit files kind of describe everything you need to run a service. So in this case, it's saying the description of the service is etcd. Okay, that's not that exciting. Run it as the user etcd. That's helpful. Permission start only. Anyone know what that actually means? I don't recall. Anyone? No? Okay. Environment, setting some environment variables. This is the actual exec start line, so this is where the init system forks. It'll fork this process, kind of after it says everything else. Systemd is a supervised init system, meaning if the process dies, it's going to try to, it can optionally restart. We have it configured to always restart and to do that every 10 seconds. And this is the run level stuff. So multi-user.target is when the login is available. So this is saying it's wanted by that. So start it when I start the console's up. We have some overlay stuff in here, but we don't need to get into that. What would be another good unit? team.
Um,
Fleet's like the simplest one in the world.
User.mount,
User.
USR.
Oh,
Not very exciting.
no. So let's just do a really simple one. Okay. Yeah, food.service. All right. I'm gonna give you the simplest one in the world. Exec start equals user bin sleep 5. I'll make that a little bit longer just so we can see what's going on. System, so I can go systemctl start. I can go foo.service. Systemd has some nice things for you. I can go systemctl. Oh, typos no. Status foo. We see it's running. Okay, and it says this is actual log entries. My process isn't logging at all, so it doesn't do anything, but it shows it's running. It sleeps for 10 seconds, so it should have died by now. Boom, now it's over. So it's now dead. And again, systemd is just kind of watching it. And that's really the simplest unit you could possibly write with systemd. Okay, so that's the systemd part. Questions there? Systemd can mount file systems. It can run the equivalent of cron jobs. The way cron jobs work in systemd are you set a timer unit, and timers get triggered at specific times to start another unit. So I could have started my sleep.service by being started with a timer. It's also cool. Another cool one called path unit, which you do a iNotify, and then if that file pops up on the file system, we'll trigger a service to run and things like that. So it's pretty cool.
I think I'm most excited about C groups. We use those really heavily
Oh.
in Space Monkey.
Totally. So, so if I wanted to, I think it's limit memory, or it might be memory limit. I don't recall, but it's essentially like this. 1 gig. So this would say my sleep can only use a max of 1 gig of memory. Obviously that won't mean much for sleep, but this is where systemd is directly integrated with C groups to allow you to do that kind of stuff. Again, all expressed through a nice little INI format-ish file instead of needing to write shell scripts to do all this stuff. So it's pretty handy, and that's why all the distros have adopted it. Cool? All right, we'll kill that guy. All right, the next thing I want to show is NCD. So I'm going to get another terminal up here. CoreOS faction equals list. Give me another one. So I'm just logging in a different machine. So NCD is running on this box. It opens a network port. You can see it's running here. This is the 7000 is its internal protocol talking between the cluster, and the 4001 is for clients. So we have a client that we include called NCD CTL. Kind of follow the whole CTL naming convention. The simplest operation here is foo and bar. Okay, so I just wrote the key foo to bar. Now foo. Now if I jump back over to this other machine, hello. Oh, that's the old one. I can NCD CTL get /foo on this other machine, and you see, hey, it's just magically there. All right. Now I could do an NCD CTL watch /foo, and actually, I don't know. Anybody know the way to split a terminal in OS X?
Command D. Oh wait, that's iTerm.
Okay. Where's my bottom of my window? There it is. Okay. And then do it again here. I need that thing, divvy. Okay. So, just a little bit too big. Sorry, excuse me. Okay. So I'm watching up here, which is essentially doing. I'll show what it's doing out behind the scenes here. But if I go NCD CTL set /foo Vaz, you'll see it immediately returns it there. And that's what allows you to do some of these more asynchronous operations, such as when you go NCD CTL set /database master is foobar.com 3306. Now I could over here be saying watch DB master, and that will cause all the clients to immediately reconfigure themselves. And so in the context of Salt, for instance, etcd we baked in as that backing data store servicing the actual configuration variables in the templates or pillars, I believe is what they're called. So, yes?
I was just going to fill that part in for you. Yeah, with Salt, you're able to call out to NCD directly from within file templates. When they're set up, you're able to call out to it directly inside of Salt's pillar, or in ad hoc ways, or you can use information that Salt generates to directly populate pieces of NCD. So we've got the returner interface in there as well. And there's many more interfaces which we should figure out how to do.
Yeah. But behind the scenes in all this is just an HTTP JSON API. So I'm just going to 4001 v1/keys, sorry, v2, I think, keys db master. And you see this is just where how the data exists underneath. And this is really why we built NCD in the first place, is because we wanted to make these distributed systems components just accessible to a normal developer, and Zookeeper is really just for Java developers at the end of the day. It's a pretty difficult binary protocol to implement, and while it seems like a maybe not so great reason to build a whole new distributed system, I think it's shown so far by the adoption of NCD that there's a need for this that just was not addressed by Zookeeper. And we believe in simplifying this will just make these distributed systems components available to more developers in general. There's a couple other things here, like, let's see, v2 leader. So this is saying that node is the active leader. You know, I could see what our machines are. I don't think I'm actually on the leader right now. Oh, I am. The green one is the leader. If I was to shoot the leader right now, you know, a new leader would be elected, and that's what NCD's kind of primary job is to guarantee that the data store is available and there's always a leader that can be talked to and discovered. Questions on NCD? Kill it. Yeah. All right. System CTL status. System CTL NCD stop. Oh, sorry. Stop NCD. Stop NCD. All right. Failed to stop. Access denied. Bang bang. All right. And then over here, curl again, and it switched to a different machine pretty instantly. And then let's just sudo systemctl start etcd, bring that cluster back up, ignore that warning, and then etcd ctl, oops, set/foo/baz. So I started the one below again, and you know it's available for writes again. So I killed it and started it back up. And then our leaders should still be 224, because the cluster, just because that peer came back doesn't mean he becomes leader again. It's forever.
Is there authentication that was on there, or?
So this is all unauthenticated localhost stuff. You can optionally turn on TLS with client certificates to have client. You get TLS, but you also get client-server-based authentication then as well. So as configured, no, this is just open, and you're using your private network to protect the transport. Okay. Any other things I should show about etcd, guys? Any other cool parts?
I'm a little curious about that discovery piece in the configuration.
Sure.
You went out and got a new token. How would you go about doing that without using that service? Get like having an etcd cluster or whatever without using the etcd.io.
Sure. Well, first I just want to show you what's happening here so you get an idea. This is the data structure that is up there now, and these are the nodes, and they're essentially doing their own service discovery, so they're heartbeating up to discovery etcd.io occasionally saying I'm alive, I'm alive. And what this allows, what this just allows a new instance to find other peers that it should talk to, and the way the bootstrapping protocol works is you have to find one other peer, then it can get enough information off that peer to figure out where everybody is to start doing all the fault tolerance. And so you would need to have everybody in here, but you just have everybody in their heartbeating. To do this without this, if you want it to be fully dynamic, you can spin up another etcd cluster, like just a single node one, used just for bootstrapping, and then point your etcds just at that, okay? Or you can just specify command line arguments that say, my peer is 10.foo, and it's just a pre-known one. But somehow etcd needs to know where the other ones are. And we could, do things like multicast DNS, for instance, but these modern networks just don't support it. Like Amazon doesn't support it, or if you want to go across the WAN, like multi-data center stuff, you're not going to be able to do that.
Yeah.
And so we just, we probably should implement multicast DNS as like a nice feature, but it hasn't been super high priority.
So that raises a good question. I think Zookeeper has some functionality that allows certain traffic to cross the WAN and other traffic not, where you can have, instead of a peer, you can have a follower that's kind of a distant cousin, I guess, that gets updated but doesn't float in the quorum stuff. In etcd, is everybody a peer, or is there some way to say, hey, these guys are read-only, or some other way to handle a slow WAN link?
I'll let one of the guys take that one.
Yeah, so in the next release, we have the concept of a standby, and the standby transparently proxies to nodes that are actually participating in the consensus protocol. And we have talked about, and probably will implement sometime in the future, the sort of Zookeeper observer mode, where they essentially get a stream of logs and are able to have an up-to-date local cache of the key store.
Okay.
But as implemented, not yet, and standby will be in the next release.
I don't want to be sensitive to everyone's time because I know we're running late. So, I could demo for, I have probably another 20-ish minutes worth of stuff, but I could also stop it right here too, if folks want.
It's fine by me if you keep going.
Yeah.
People can leave if they want.
Also, yeah, feel free to get up and leave. I won't hold it against you. I realize it's late.
So when you're
yeah.
bootstrapping, you had your own code that started some things in Amazon. How do your customers that you're working with typically boot? I guess
Yeah.
Salt is one option, right? Or
So for the boots, like the initial boot time configuration,
to start the nodes in Amazon.
So first, to launch machines in Amazon, you can do that through whatever mechanisms you want, through the control panel, through Salt, through Vagrant, through however you want to do it.
Have you noticed any trends among people you work with of what they tend to do?
People like the Amazon Cloud Formations,
Wow.
that kind of stuff. Yeah, I know.
Cloud formation and like in the same sentence.
Well, we make it relatively easy. You just launch it. And again, most people are just playing with this stuff right now and tinkering around with it. So we want the easiest way to a cluster. Typically starting at the cluster level is, we want to make starting a cluster as simple as starting a single machine, but currently, state of the art is you have one machine and that's an easy thing to deal with for a long time. Then you enter this whole new world when you decide to do multi-machines. And so we're trying to make it as simple as possible, and that's where a cloud formation does make it easier. But we've used all sorts of things. We used Fabric. We've used I wrote the CoreOS thing just because I wanted to learn Go, that kind of stuff. But the key is that this config file for boot time initialization is consistent wherever you run CoreOS. So wherever you run it, we figured out a way to allow you to inject user data, whether that's in a PXE image or that's in a Amazon machine or Google machine. And if you were to boot this on a Google machine, an Amazon machine, and a PXE image, and the networking was right, they'd all come up in a cluster together as well. That's actually why I built Core up, because I wanted to bring up rack space in Amazon and Google machines and create Google's on, and, that whole thing. So, but haven't caught there yet.
Salt Cloud would do that pretty fantastically well.
Okay, well there we go. That's a place probably could work together on this, and that we're just not as familiar with.
Yeah, no, that's definitely something, we'd be quite thrilled to talk to you about, because we could probably get systems inside of Salt Cloud that could spin up a cluster across 10 different clouds, and we could probably get that going in a few days.
Yeah.
So that'd be pretty freaking awesome.
The advantage of, one key thing is if you're on a version of CoreOS on all of those different platforms, you can do a signature validation on the root block device and have extreme consistency. It is exactly the same on every single platform. It is not one config file different here and there. That root block device where all the core bits are is bit for bit identical on every platform we run on, which is like a prerequisite for actually doing all these multi-cloud stuff and making that reliable. Yeah.
How mature is Fleet? It seemed like when I first read about it a few months ago, it was kind of something you were trying out. Is it now kind of, what's this current status?
Walden?
Yeah, so we're actively working on making it a real stable platform, because if people can't trust it, then it's really just useless. Like, we don't want to build a bunch of fun little tools that we just forget about and move on. So we're actively working towards stabilizing it and making it work for real use cases. So to answer your question, I wouldn't say it's stable and ready for production today, but there are people running it in production today.
Yeah, point 2. And I think the feeling point 2 gives you is appropriate for where it's at.
Yeah.
And we are all, like, the thing we're all actively heads down on, you know, in or out of the RV is getting to our 1.0s on all these things. And that doesn't mean we'll have 8 releases between now and then to do that, but getting these things to a point where they work, and they just work as expected, and tools like NCD and Fleet without feature creep are just, like, they work or they don't work. Like, it's not a, there's not all these crazy things, it just works.
This may be a hard question to answer, but what are the competitors to Fleet? I've kind of looked for something that would, I mean, there's a lot of things that do configuration management of a single server, but I haven't seen much that can say, I want to make sure they're exactly in things running, and if one fails, restart. You know, other than Fleet, since you guys probably know the landscape a little bit, who else is out there that does that?
There's a couple. So Yarn is the Hadoop Suites version of this. And it uses like Zookeeper and stuff, does, you know, similar set of things, process execution. Mesos is another one. Mesos here is the company. Mesos is another Apache project. Jonathan, what would you say are the differences?
Aurora is more
Aurora?
more directly analogous.
Okay. Aurora, Mesos. Aurora is Twitter's implementation. Actually, could you just explain it real quick? Jonathan was formerly at Twitter working on Aurora, so can you explain
So
it?
Mesos kind of just deals with like the underlying like health of the cluster and like how many resources each machine has available and all that kind of stuff. And it just deals like with very rudimentary, like considers tasks, but it doesn't have any facilities for kind of, you know, ensuring that they keep running. But you pair up Mesos with like a scheduling framework. So Twitter's is Aurora, and that's responsible for like saying, oh, I want 10 instances of this to be running in my cluster at any one time. And so it will kind of submit those to Mesos, and is kind of in constant communication with Mesos. And when it, you know, hears back that, oh, this task has died over there, it'll schedule a new one. So it's fairly analogous to Fleet, but
Fleet really, like, we look at it totally as take systemd and abstract it across a bunch of machines. Mesos is really nice when you want to build your own kind of distributed system. It's like an SDK for distributed systems. Mesos provides resource scheduling and pluggable frameworks on both the scheduler and the executor side. In our world, a scheduler is always Fleet, like it's the Fleet engine in our taxonomy, and then the executor, the thing actually running the process, is always systemd. So we hook you directly into the init system. And I like to say that you could go deploy, you would go deploy Mesos on top of Fleet. Similarly, how Fleet needs to run on a Linux box somewhere, Mesos has to run on a Linux box somewhere at the end of the day, right? So does Hadoop. So that's when we get back to this whole undercloud thing, is you need something on, like, below to run these higher order platforms, right? So while we're on that topic, let's see here. See how things are looking. Okay. So let's just do this really simple one. So I'm going to just do a Fleet job here. So again, you'll notice this is just straight systemd syntax. No magic sauce here. So similar to how we had systemctl start, now we have fleetctl start. Just trying to carry the analogy forward. When we run this, that was a blocking job until that was running on an init system somewhere. Okay, now this is a pretty small cluster, so It's fast, but our goal is to keep it really fast. So that test.service landed on 224. You know, I'm on 225 right now, but that one got out there. Everybody following what just happened?
Mm-hmm.
Okay. So I'm going to schedule a couple more. Doing my little T trick. Everyone know their bash expansions?
Yes.
That just expands out to 5.services, and then piping it to T so we can do, and then, okay, we have all these here now, which are just identical copies of the file. Everybody following me? Okay. So I'm going to just launch all these. More bash expansions. Okay, so those are all out there. We list units. We can see that they are just running somewhere randomly, somewhat seemingly random, right? The core thing I wanted to show here is, I forgot one thing. I need to set forward my SSH agent, and then Fleet has some features that will allow you to kind of SSH around the cluster to see what's going on. So if I go fleetctl SSH test1.service, it's just going to land me on this box 223 here. Okay. Now you can go systemctl status test1.service, and then I'm just going to go ahead and nuke this machine. Oh, I'm double logged out. So I killed that host. And do you remember where it was before? 223. And now it's running on 224 because I just powered down that machine. And that machine's like totally dead to us now. Like, I don't know how to recover it from that. So Amazon doesn't think it's dead, but I've just powered it off, so the init system's down. And I'll just have to go terminate that host when we're done with the demo. But that's like, that's Fleet's core job, pretty much, right there. Yes?
So when you do the fleet control start, it actually is copying that service, that unit file out and then starting it? Or how does it propagate, I guess is my question.
I'll show you with the code. So what happens is essentially you're saying, help me Walden, payload?
I'm sorry, yeah, payload.
What you're saying is these are the things that need to be running somewhere, and NCD is persisting them because it's saying like this is the source of truth that never goes away because we are a distributed fault tolerant consensus algorithm, and we will guarantee that for you across network partitions and everything.
So when you typed vi test service, where did you put that?
It's just right here on my local file system, which has nothing to do with where it exists in the cluster. This just gets copied and written to etcd.
Okay.
So if I do etcd ctl get this, there's the contents of that key. I could alternatively go fleetctl cat, I believe, right?
Yeah.
You know, and that's grabbing just that portion out of there.
So my follow-up question is, how crazy can you get with putting files into etcd?
Like how many?
Can I put like JPEGs in there and be really evil?
I mean, you'd have to base 64 encode it, but yeah.
So you don't handle binary for us, which is probably good.
Yeah, no, we don't.
JSON.
Yeah.
JSON's horrible for binary data.
Yes.
Yeah.
That's kind of, it was kind of a troll question.
Yeah, you could go nuts and put a lot of stuff in there and at some point it breaks. I mean, it's not. I mean, it's not.
Well, I guess
magical.
my point is I'm not going to want to like distribute like build artifacts or anything.
No, not through etcd. You still want to do that.
That's what I
Your
figured.
classic way.
Yeah.
Whatever that
Through
is.
your Docker, like, image servers.
Right. So, I mean, so
Yeah.
let's like level up here.
Before you move on, where do logs for all these services go? Do you have like a logging system?
Softball, fleetctl,
right.
journal, test1.service. So this is just interacting with the systemd journal, and
Nice.
systemd has
And
kind of all the stuff
across
in
all
there.
the.
Yeah, so actually, let's write a new one. Echo foo Walden. It's gonna work.
The
problem-
I'm trying to do, so I can't tell you if it's gonna work.
Actually, yeah, the problem is, I just want to get the logs, and then I'm going to user bin sleep 3000. because I don't want the process to exit. Okay, so no whammy, fleet CTL, journal, foo.service. Oh, it did exit on me. It exited on me because it was just, it echoed foo and then it didn't actually sleep.
Maybe if you wrap it in like bash C quotes.
Yeah, that would work. Or let's do, so fleet CTL destroy foo.
5.
Take it down, and then we're gonna exec start pre equals user bin echo foo, and then we're gonna daemonize with our sleep.
Oh, Polvi, if you want to combine it into one exec start line, you need a space before the semicolon and after.
Thank you, system.
Yeah.
Okay. System, sorry, fleet CTL start foo.service. And now give me the journal. There we go.
Wow.
Yeah, so you just echoed before there. So, you got it. So that's that, and that's the just interacting with systemd journal. That'd be equivalent of, let's see, let's see list units again. I'm on 225. I have nothing running on this machine I'm on, cool. But, well then, sorry, fleet CTL SSH foo.service, and then journal, excuse me, journal CTL-u foo.service. So, this is gonna, I just hate the pager, but this is just the raw systemd journal here. It's the exact same thing, okay? But the cool thing about the systemd journal is they give it actually a lot of other neat features, like JSON. And it's like, okay, now, hello everybody, we have entered 2014 and we now have like a log entry that isn't just this unstructured piece of text. It actually has structured data tied to it, like what was the executable that ran, or what was the C group that it was in, or what is this crazy cursor, I don't know what that is. But, and then it's somewhere in all this mess, there's the little log string, there's the host name of the server it ran on. And that's all like queryable and indexable because it's actually structured data. And the systemd journal gives you that versus it just being a flat text file. And yes, this kind of goes against the Unix philosophy a little bit of simple stuff, but it's also like, come on. It's like,
screw Unix.
Yeah, screw Unix. How about let's query log entries between this time range. Why do I have to write Perl for that? Like, should be a thing. Okay. I want to show you just a couple other things before I get my burrito. All right, so blah.service, well, I'm just going to tear it down again. Bye-bye, foo. Welcome back, foo. Okay, I'm just going to call this foo2. So you can specify some things in this fleet section. These are our directives that are cluster level directives. So one would be X, which one should we start with? Conflicts?
Sure, sounds good.
Okay. So this is saying, run me wherever there is not already a service called foo something running. Okay? So this is how you get anti-machine affinity. So saying, I want to run this process, but make sure I'm not running on the same physical host or the same fleet host as another process. So you start spreading things out for fault tolerance. So I conflicts with foo. I'm going to do my little T trick again. How many machines? That service. So I just have 6 of these now, right? Or 7, 8 foos. They all have this conflicts line. And I'm going to go fleet CTL start foo. Chug, 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 chug. Oh no, it quit responding. Why would it possibly stop scheduling? Anyone?
Because it has too many, there you go.
Great, they're already running. So these guys can't schedule because all the hosts, there's only 4 now because we lost one because I powered it off. There's only, there's 4 right now, so we can't schedule, right? So why not? Let's core up. So I'm going to bring up another machine. I think by default it will do what I want. So this is launching one machine. So that by default action is run and num equals 1. So I just booted one host, okay? And then while that's going, show one little trick here with fleetctl. Since we're all doing everything in Go, we can set an environment variable, this fleetctl tunnel, and I can run this from my laptop and start doing my fleet commands this way. So this is going to start, it took me that host and this machines, there it goes, being tired. Still 4 machines, so hopefully I thought the Amazon machine would come up that fast, but it hasn't come up yet. But you get what I'm doing? So from my laptop now, I'm controlling the fleet cluster. What's happening is it's tunneling it all over SSH for us automatically. I'm running this. There's still 4 unscheduled.
So
Hey,
those
there's
will
a
pick
5th
up-
one.
So I was just gonna say, so those will pick up as soon as those sleeps expire.
No, so what happened is these are all conflicting, these foods, meaning they're spreading across the cluster on different machine IDs. They're all on different machines. The 4 of them couldn't find a machine because there's only 4 hosts up. And I scheduled like 8 of them, or whatever, that's 4 plus 4. I scheduled 8, but there were only 4 hosts available.
Right, but all of those services are only sleeping for 3,000 seconds.
Oh, right, yeah.
So as soon as those sleeps expire, they'll kick in immediately?
As soon as the sleeps expire, the
Because
process.
those are pending queued jobs?
No, so in this case, the sleep is just like the daemon. That could be Apache 2 or whatever. So when that sleep and that 3,000 ends, the job is just done and dies.
Well, right, that job dies, but then you've got those 4 that are waiting for someone to live.
Actually, I've never demoed that, but that would work quite well.
But can I answer that question, Polvi?
Yeah.
That won't happen because everything's considered a service job right now.
Okay.
Once we have batch jobs where a job exits and is removed from the system, then it could step up and take those services.
Oh.
Gotcha.
I was over committing under delivering. Okay.
What are you, a CEO?
Yeah. Okay, so look, we got our 5th machine here. So this is like the grand finale of the magic trick, if it works. So we had 4 pending. So cross your fingers. No baby needs a new pair of shoes and all that jazz. And SSH is, and there's only 3 now left over, right? Woohoo! And then let's do it again. Let's just bring up num equals 3. Let's just bring up 3 more.
Well, I hear the salt thing's a bit faster than SSH.
Yeah, definitely. This is, again, this is our fleet binary just tunneling stuff over the host. You could run, the commands, as you noticed when I ran them here, were much faster. You run them directly on the host. So anyway, now we're going to wait for 3 more machines to boot, and that's not very exciting. And that concludes my demo.
Docker?
Any questions? Oh yeah, Docker, sorry.
Sorry. It's like a laundry.
So I mean, it's pretty simple stuff. Exec start equals user bin docker run busybox bin /sleep 3000. And now we successfly wrapped that in there, and
That's really it. Yeah. That's pretty.
and now that's running.
Too easy.
One thing I wanted to show you really cool about systemd, I forgot on that part of the demo. This is probably overkill, but I really think this is cool. So with systemd, now we're just talking about systemd for a minute, forget about fleet and all this stuff. But systemd has this concept of socket activation. Anyone familiar with this?
Yes.
Okay. Well, I'll explain it anyway. So you guys remember the iNet days where the init system would hold open a port, and then when connection would come in, that would get passed to, it would fork a process, pass that data off the connection into that standard in of that process, and then it would just write to standard out, and that was what come back out the socket, right? That's cool for things like SSH, but it's not cool for things like HTTP, because you can't fork an HTTP server on every single HTTP request, right? But on the other side, you want to daemonize a process so it can accept everything. So what systemd allows you to do is sort of split this halvesies. It says, I'm going to listen on the socket for you, and then start the service and then hand that file descriptor to the service that I forked. So that means that this thing has to be aware that it's being socket activated, but the code to do this is like a listen off of an FD instead of a listen and bind, right? And it's getting passed that FD over an environment variable. And so you'll notice right now docker.socket is listening, but the docker.service is inactive, meaning we don't have anything running on this host. Like the Docker daemon isn't running on this host at all. But the socket, which is var run docker.sock, is there. So if I was to do like a docker pull busybox, we'll see it starts chugging away just like it was working. Like, cool.
Can you configure in your like cloud config whatever what the Docker image repository is? Like, do you want to not use the global one?
So you specify in the Docker world. Let me just get to my punchline,
Sure,
and then I'll do that. So now if we go to docker.service again, you'll see that systemd started it, and then we get all the logs from everything. And this is really handy for two things. First is to make boots really, really fast, because this solves inter-service dependencies really elegantly. What systemd will do is bring up all the sockets first. So you'll have like your Docker socket, your MySQL.socket, your whatever, your cups socket if it's your desktop, and bring up all the sockets, and then it'll launch all the services, and they'll just try to connect to each other. So let's say your web app is on the same machine as your database. It'll just try to connect to its database socket, which will force systemd to start that thing, and it'll buffer that connection until the process is started and running, which allows you to just essentially say everything start all at once, and those inter-service dependencies will be kind of resolved for you. So we boot really fast because of this. We boot in like a second and a half or something. The other thing that's really neat is that processes, if they're well designed, can self-garbage collect. They can just shut themselves down, and the socket will still be there. And if they shut themselves down, the socket's there, the next incoming connection will fire them back up again. So if you have a really dense cloud platform, or you want to build this multi-tenant cloud thing, but not actually have all these processes running, so you can oversubscribe everybody, this would be a really handy way to do it. Or also just a way to keep things running. So I can go systemctl stop docker.service. We'll see that systemctl status docker.service. We'll see it's failed, it's exited, right, and all that, and then I can pull busybox again and status, and it's fired back up again, and the end user doesn't do it. Anyway, just an aside on that one. Your question: how do you change your repository? So the way Docker does that is, and this is just pure Docker stuff. You go Docker.
Yeah, that might be a new question.
foo.myrepo.com/
oh yeah, new question.
thing.
Yay!
And so that will cause Docker to query from foo.myrepo.com and look for the thing container, which is if you're running a private registry.
Can you talk, okay, you should go get your burrito, but I would be interested in hearing more about, you mentioned boat.
Boat? Blake? Okay, he was asking about boat.
Okay.
How about we do this? So, guys from the CoreOS team that are hacking on Fleet primarily, could you raise your hands for just a second? So it's Walden and Jonathan. And then on NCD and Raft is Blake. Raise your hand, Blake. And Yichen, who's over here. And then, what other stuff did we build? The distro itself, actually, the distro guys aren't here. They're back at the office still, working hard. And then Brandon can answer pretty much any question. But how about we call it, and you have all core devs of all this stuff here, so we should be able to answer any questions you have. So, do you have anything else? I'd like to thank you all for hosting us and staying so late.